Hi everyone. So we will solve this question. This was asked in GATE 2024 in data science in AI. So if you're going to learn this question, how to be solve this, okay. So those who have attended my class on linear algebra, so they will be able to solve. But this question can be done by solving question by contradiction, right? So you have to read each and every statement, and if you know the fact, okay, when we can have the unique solution, when we can have the infinitely many solutions or no solutions, you can solve this question very easily, right? And if you have the idea about when there will be a balanced system, when there is a overdetermined system or underdetermined system, right? So I have discussed all the detail in the classroom, but in this solution I'm not going to discuss the detail. I will solve this question by contradiction, right? So you see here, this question was asked in GATE 2024 in DA paper. Okay, so this kind of solution you will not find on any YouTube channel, that I can say. Okay, so I'm just offering this solution, and this solution can be done by contradiction, right? Okay, so what is the meaning of that? Let us read the question first. Which of the following is are true, right? So it is a MSQ question. So if you don't have complete knowledge of linear algebra, if you know only how to solve matrices and determinant, because many of you are a blind follower of somebody where people only teach what, the matrices and the determinant, that's it. That is the course which is taught by most of the people, not few, is taught based on class 11th and 12th, whatever matrices and determinant concepts are taught in 11th 12th, right? But linear algebra is totally different settings, right? You need to understand linear algebra in the language of vector space, okay? Because vector space is nothing but what, the heart of linear algebra, and you should have the complete knowledge about system of linear equations. So there are three situations that is possible in system of linear equation, right? Based on the number of equations and number of variables, right? So that is one important thing, okay? So if the number of equations and the number of variables are same, right? Number of variables means number of unknowns. Number of unknowns means number of column present in the matrix, right? And a number of equations means number of rows, okay? So I have discussed all those things in the classroom, right? So we will solve this question very quickly. Okay, so after solving this question, if you want to join me, you can always reach out to me via my WhatsApp number, right? So let us read the question. So I have read the question already. Here R represent the set of real number. Okay, let us go through first option and eliminate it if it is not correct. Okay, so what they have given here is there exists a matrix, okay, which is 3 by 3 matrix. Okay, like number of rows and number of columns are same, and the vector p is there, which has three dimension, I mean three components are there, and vector q is also there, which has also three dimension. Q is a three-dimensional vector, right? Now first is nothing but what they are saying, that such that mx equal to p has a unique solution. So can you tell me when we can have unique solution? See, when we have the unique solution, if they are claiming that in this statement it has unique solution, it means the matrix will be what? Matrix will be having the full rank, you can say, right? Okay, full rank means the matrix will be invertible matrix, or the determinant of the matrix will not be zero. If determinant of the matrix is zero, means the rank is going to be not the full rank. Okay, rank will be always less than what, less than the number of rows or the number of column, you can say, right? Okay, I hope that makes sense to you. Okay, so if the matrix is non-invertible, I mean if the matrix is non-singular, then only you can have the full rank. So for unique solution you must have, and as far as this matrix is concerned, this matrix is a square matrix. Okay, so this matrix is invertible matrix. It means that the determinant is not equal to zero. Okay, so this matrix can have the unique solution. Okay, mx equal to p is only possible, has unique solution when it has full rank. It means it has full rank, and rank will be equal to 3, you can see in this case. Okay, but what is the second part of the statement? Mx equal to q has infinite solution. So first of all, this q will be in the column space of a matrix M, right? But when we can have the unique solution, when we can have the infinitely many solutions, when there is a free variable, it means that the rank of the matrix will not be equal to what, the column of the matrix, or the you can say the if there is a infinitely many solutions, means the matrix does not have a full rank. Okay, certainly the matrix will be having the rank which is less than the variable. Okay, like unknowns, you can say, understand? So there will be a free variable. If there is a free variable, it means it will it means what? The matrix M is not invertible matrix. Okay, matrix M is having the determinant equal to 0. Okay, so when they are saying that it has infinitely solution, means M will be equal to 0 in this case, right? But in this case M should not be equal to 0. Okay, then only you can have the full rank. Okay, so this statement is eliminated. This is what the solving question by contradiction. We are eliminating options by contradiction. You know that all these things, right? So if we want unique solution, and this equation is given, the system of linear equation is given balanced system. Okay, number of equations and number of unknowns are same, so we can have the matrix. Okay, and matrix must be invertible matrix. If we want invertible, meaning what? The determinant should not be equal to 0, then only you can find the inverse of the matrix. So you will be having the unique solution. But as long as they have said that second part of the question, second part of the statement, mx equal to q has infinitely many solutions, it means that there are free variables. And when we can have free variables, when the determinant is equal to 0, or any or you can say the rank is not going to be the full rank. Okay, so we can't have the full rank in this case. No full rank. Okay, no full rank, and there will be a free variable, right? Yeah, fine. So option A will not be correct here, right? Now let us go to second option. There exists a matrix M. Okay, again 3 by 3. Okay, all the vectors, all columns are 3 by 3. Okay, and P is a three-dimensional vector, Q is a three-dimensional vector, all are real, set of real numbers. Okay, now what they are saying is mx equal to P has no solutions, and mx equal to Q has infinitely many solutions. So let me again solve this question by contradiction again, right? So you see here, mx equal to Q has infinitely many solutions. What is the meaning of that? The matrix is what? The matrix, the determinant of the matrix is going to be 0. Yeah, certainly. And if there is a infinitely many solutions, means the equations are consistent. Okay, and there will be a solution will exist, but there will not be unique solution. Yes, but the solution is going to be existing. Okay, so and this q will be in the column space of M, right? Okay, so here we can't achieve the full rank, but solution will exist. Okay, solution exists, you can say. Understand? Solution will exist here. So what you can say, what you can comment here, what they are saying is mx equal to P has no solution. What is the meaning of that? So there exists M belongs to R 3 by 3 and P is R3, P belong to R3, Q belong to R3. Okay, so mx equal to P has no solutions, mx equal to Q has infinitely many solutions. See, so mx equal to P to have no solution, it means that what? This P will not be inside the column space of a matrix M, right? Okay, mx equal to Q means what? Q to have infinitely solutions, Q must be in the column space of M. Okay, so M will be what? It will not be having full rank, guys. Let me recall you. Okay, if there is an infinitely many solution, no full rank. Okay, so if rank is what? If M is what? Having not a full rank. Okay, so there can be a cases where some P, okay, some P might not be in the column space of you can say some P might not be in the column space of M, you can say, right? So no solution you can have, while other Q could be in the column space of you can say so we can have okay, so this is a possible situation, right? Okay, this we can have, certainly we can have this answer. Okay, correct. Okay, so B will be the correct here, right? Please do remember this. Okay, so there is nothing like any contradiction in this case. Next, so no solution is possible. Yes, if P is no, some P is not in the column space of M, means yes, and this is also possible. But in place of you know solution, if they might have given unique, just like option 1, so this option will also be eliminated. Next, there exists a matrix. Okay, you see here there exists a matrix which has the dimension here 2 by 3. So any matrix is there which has the dimension 2 by 3. What is the meaning of that? The meaning of that is, okay, the number of equations are what? Number of equations are less compared to number of unknowns, right? So this option cannot have unique solution, guys. It is for sure. Okay, this kind of system of linear equation, because this is what? Underdetermined system. Okay, see, two equations are there and three unknowns are there. See, two equations, three unknowns. So it is underdetermined system, right? You want to find out three unknowns, right? But they have given only two equations. Okay, so how can you find the unique solutions? How can you find the value of x1, x2, x3, right? Okay, so there cannot be unique solution, right? So let us go through the options. So what they have given here is, in this case, unique solution is not possible, and they have said that there is a unique solution. So this option will be eliminated directly. Okay, it is a underdetermined system. Two equations, three unknowns. Okay, if you have got many unknowns and only I have given you two equations, right? So if the number of equations are less than the number of unknowns, okay, this kind of system is known as you can say underdetermined system, right? And there we cannot have the unique solution. Please remember, we can have no solutions or infinitely many solutions. Yeah, no solution, infinitely many solutions are possible, but in this case, as you see, they have said that mx equal to p has a unique solution. Okay, why? The reason is rank will be always, okay, rank will not be equal to 3. Remember, in this case, rank can be 2 or rank will be less than 2. Okay, next, option D. Let us go to option D, right? So there exists, again they have given this kind of equation, right? The matrix is of 3 by 2. Okay, so you see here, guys, there are how many equations? There are 3 equations and there are 2 unknowns. So this kind of system is known as what? This kind of system of linear equation is known as overdetermined system. See, you need to find 2 unknowns, but they have given 3 equations, right? So it is a overdetermined system, right? So we can have what? We can talk about what? We can talk about unique solution as well, and we can talk about no solutions. Okay. So unique solution means what? Unique solutions. Okay, we can have unique solution in this case. So option D can also be correct in this case, right? Option D is also possible, right? Option D is also possible. I hope this makes sense. Okay, so option B and option D will be correct for this question. So I think you might have understood. So let me summarize everything here, right? So you should know that if there is a system of linear equation, okay, that is ax equal to b, non-homogeneous system of linear equations. So there can be 3 possibilities. So let me again warn you, whenever you look at the system of linear equation, don't start solving the question. Okay, first of all, make observations, right? That whether this is a overdetermined system or underdetermined system or balanced system. So in case of balanced system, you have to only check the consistency, and then based on the consistency, if it is not consistent, then no solution will be there. And if the balance system is consistent, okay, I think you know how to find the consistency, finding the rank of a matrix M or finding the rank of the augmented matrix, right? And if there is a solution, okay, unique solution, so right hand side will be in the column space of a matrix. Okay, please do remember that. So we can have 3 situations. One is the balanced situation. If A is M, you know, what we are considering here is A can be M by N, right? So if M equal to N here, in this case M is you can say less than N, in this case M is greater than N, right? So if number of equations are less, so it is nothing but underdetermined system. Okay, and in this case overdetermined, right? Okay, so we can have all sort of situations, right? So you have to first check the consistency, right? Okay, so consistency check karna hai, and then you can have further unique as well as infinitely many, right? So I'm not going to further detail this, right? This was the solution. Okay, and if you are going to follow my lectures on linear algebra, as far as gate data science and AI is concerned, you will be able to solve all the questions. Okay, and you might score more than 35 marks, okay, in the gate data science, you know, along from the mathematics, because mathematics weightage is very high in gate data science and AI. Okay, and I teach gate data science and AI mathematics as well as aptitude and all other subjects. Thank you.